Here is a question that trips up most engineers. You have a table, 50 billion rows. You add one column. How long does that take? If you are picturing a slow, expensive rewrite of every file, stay with me. The answer is almost zero. Delta Schema Evolution, where the data barely moves. First, what a delta table really is. It is not one file. It is a folder inside your data as Parquet files, and next to them, a transaction log. The log is a stack of versions, append only. Each version is a few small actions. Add a file, remove a file, change the schema. The log is the single source of truth, and the schema lives inside it, right next to the data. No metastore, no proprietary format, just an open table any engine can read. So where is the schema? It is an action in the log. One entry called metadata. It holds the whole schema as text. That is the key idea. If the schema is just an entry, then changing it is just a new entry. So watch ADD column. It writes one commit. That is it. Not one Parquet file is touched. The old files never had the column, so on red, the engine fills it with null. 50 rows, or 50 billion. Same commit, same time. The work is not a rewrite. It is a single line in the log. Now the part almost nobody knows. How do you rename a column with no rewrite? Or drop one? The trick is column mapping. Every column gets two names. One logical name, the one you type in queries, and one physical name, a fixed ID like ', then a UUID. That physical name lives inside the Parquet file, right beside a 32-bit field ID. So your query asks for full name, but the file has never heard a full name. It only knows :ASO1F4. The log holds the map between them. Now rename the column. Only one thing changes. The logical name in the log. The physical name never moves. 0 files rewritten. Drop a column? Just remove it from the map. The bytes stay on disk. Simply never read again. This only works if the reader understands it. So the protocol keeps a list. Table features, column mapping, deletion vectors, type widening, each one named. A reader checks the list, knows the feature. It reads, does not. It refuses. It will not guess, and it will not misread your data. That is how the format grows new powers, without breaking the old tools. Types work the same way. Turn an int into a long. The old files keep the int. The reader widens it on the way out, and the change is written in the schema as type changes. Again, metadata, not migration. None of this is theory. Let us watch it live on a real table. Here is the table DeltaForge built. Look at the properties: column mapping, mode name, reader version 2, writer version 5. That one block is what turns on everything we just saw. It is an ordinary directory. 40 employees, 6 departments, real data in a real Delta table. The location column was added with alter table after every one of these rows already existed. No file was rewritten, so they all read back null. An instant schema change with 0 I/O. Now the moment that surprises people, rename full name to display name. On most systems, that is a full rewrite. Here it is instant, and every value is still there, because on disk, nothing moved. Only the logical name in the log changed. Drop a column? Same story. Gone from the schema at once. The bytes just stop being read. And every change we made is one more version in the log. Same standard delta table, evolving at metadata speed. So when do you reach for this? Anytime the schema has to change, and downtime is not an option. New fields as the product grows, a rename for clarity, a type that outgrew itself. With DeltaForge, every one of those is a metadata commit on a real open Delta table that any engine speaking the protocol can read. Standard tables, evolved at metadata speed. That is DeltaForge.